about meteor showers now, but yeah. So hopefully, and I actually put the link up there on Twitter too, hopefully you remember the video we saw on Wednesday. I thought it did a really good job. So asteroids and comets are kind of left over from the formation of the solar system. Most asteroids are not spherical because they're actually kind of not big enough to kind of round out their edges. Most of them kind of look like the captured moons of Mars. So, but the most asteroids are located between, of course, Mars and Jupiter. But if you took all the asteroids and combined them together, it would not equal one planet. Asteroids actually can be seen only as they reflect light, and you can see them then over the course of the same night. Actually, they look like a streak against the background stars. So that's kind of what that is. So there's a picture of the asteroid belt. Now, actually, there are two other types of asteroids, and I don't think the video talked about this. There are Trojan asteroids at these stable, what we call stable Lagrange points that escort Jupiter. They're in Jupiter's orbit, a few ahead and a few behind. Earth actually also has Trojan asteroids. And the third type of asteroid is an Apollo asteroid. An Apollo asteroid is the type of asteroid that actually is kind of a little bit random, and it actually crosses Earth's orbit. So this slide is kind of showing you the whole asteroid belt was kind of disturbed. That matter could not come into one object because the gravity that Jupiter held over it. So one of the things down here that I didn't like about the video is it kind of went with the whole, and maybe with this was, I'm thinking of more Saturn's rings, but if you were in the asteroid belt, you wouldn't have to be kind of dodging asteroids. There's a lot of space between asteroids, okay? So that's kind of a myth. I thought they kind of showed that incorrectly. So the three M's, and this is actually in the order that they exist. We have meteoroids, meteors, and meteorites. And can you probably see the oid in meteoroids? Okay, that's how I remember it, because an asteroid, a meteoroid, actually they're very similar. A meteoroid is smaller. So a meteoroid is actually a space rock, still out there in outer space. So meteor, you think of meteor showers, okay? So a meteor basically happens, it's that flash of light that's created as something falls through the Earth's atmosphere. It could be a spaceship that lost its, went into decay orbit, or it could be a space rock. Then if anything hits the ground, I like the video that we watched because remember that one guy's car got hit by, by a meteoroid creating a meteor, and then he picked it up as a meteorite. That'd be worth a lot of money, okay?
That'd pay for the repairs.
I would hope so. I thought the video did a good job kind of differentiating between these different types of meteorites that you can pick up. I also liked what the video talked about. Did you catch that basically the Earth is picking up like, I don't know, hundreds of tons of mass each day because of stuff falling through? It's not just the cool streaks, it's the what they call micrometeorites coating the Earth. And this kind of emphasizes actually, I know, and it seems like a stretch for people, especially if they're not kind of into science, but we can identify rocks that originated from Mars, the planet Mars, and we can identify rocks that originated from our moon, with a capital M. Both comets and asteroids are left over from the formation of our solar system. Comets generally are on the cooler side of the frost line. Although the documentary we watched talked about how it looks like the nucleus of comets actually look like it's been processed, so it was closer to the sun at one time. So that was kind of interesting. And I really liked what that gal with the red gloves did, making the comet. Was that not cool or what? Yep. So the two locations of comets are the Kuiper Belt and the Oort Cloud, and I think we've run into these before. The Kuiper Belt is basically in the plane of the ecliptic, and the Oort Cloud is bigger than that, more spherical. So I also like what the video talked about. It said, well, how do you, by the way, most comets, you don't see them fizz, okay? We think of comets, and we're going to see some pictures of comets, kind of that cool streak through the sky. Those comets out there in the Kuiper Belt and the Oort Cloud are basically not close enough to the sun to begin that process like we saw on the video. So they get nudged by gravitational influence of something or some things, perhaps Neptune, or I've even heard a passing star. Okay, so we only see comets when they get close enough to the sun. And let's see, what else do we do? I'll just put this whole thing up here. You only see comets when they get close enough to the sun. So here are a couple of different pictures of different comets. Comets are named by the person who finds them. So we have, looks like somebody in Japan found Comet Hayutake, and Comet Hale-Bopp there is on the right. Of course, Halley's Comet is a famous one. It's got a really pretty short period, 76 years to return. Now, a comet can go around the sun only about 100 times before each time it goes around, it loses some of itself. Yeah. So, and if you, like me, you've seen some of those. NASA has posted that some comets actually we know are kind of kamikaze comets. Basically, they don't go around the sun; they just go right into the sun. Okay. And these are a couple of pictures. Oh, by the way, up there I put the website. www.heavens-above.com. It's good actually to see what sort of comets are out there. It's also good to see what your International Space Station passes are, and if you're going to have any iridium flares. It's a really good website, really solid. I went there, and there was a comet this fall that was going to be visible. It's called Catalina, I think. And I went, and actually it's like a southern hemisphere comet, if I'm looking at it right. So no road trips for us. I'll double check, but... so last fall, though, we had a comet out and about, and actually this is Comet Lovejoy, taken through the telescope I had out there last night. It's definitely got the green thing going on. Not much of a tail. It's all what we call coma, kind of that fuzzy ball. But I enjoyed watching it over the course of, several months, I think. So what makes up a comet? Well, when it gets close enough to the sun, it begins that fizzing process. So I really like this figure from your textbook. This little nugget right here, that's actually what we call the nucleus, and it's hiding in the coma. So the nucleus is the rocky, sort of icy rocky thing that has not been has not begun fizzing. And then you have kind of this spherical region around the nucleus called the coma, and then you have a couple of tails. Okay, so your couple of tails are actually a plasma tail and a dust tail. The plasma tail is straight, and the dust tail is kind of arching. And actually, if you, I think if you look back at a couple of comets I showed you a minute ago, you can actually see two tails. The straight plasma tail will always go directly away from the sun, and the reason it goes away from the sun is because the sun's solar wind. You're welcome. All right, so that's all that. Pretty good. So this actually is a close-up of a comet, and the comet's kind of breaking up. This actually was something that was mentioned in the video we watched. And remember when they talked about comet, this is Comet Temple, Comet Temple was visited, and the spacecraft then ejected like a missile at the comet. And I think they were surprised that, kind of like back to the video, when she made that comet, it seems like if you hit it right, the whole thing would fall apart. Okay, this actually had more togetherness than they thought it might. It just made a crater on it. Meteor showers. So like I said, we have a meteor shower going on right now. But I told you a rate of about 10 to 20 for the Draconids. The cool thing about this meteor shower is actually it's near a new moon, so you don't have the moon in the way. But even without a meteor shower, you're going to see about 10 streaks. One streak every 10 minutes. So I guess that is pretty good if they're saying a rate of 10 to 20, I think, per hour. No, 10 to 20 per hour. That's still not very many. So 1 every 10 minutes. So if you knew where to look, in 50 minutes you could knock out your lab if you're after 5. It's a thought. But they're pretty random. Now, when we have a meteor shower, they are not random. They come from what we call a radiant. So for the Draconids, it would actually be a radiant in the constellation Draco. So if you're ever, oh, there's a meteor shower, where do I look? Well, look at the internet and they'll have a picture of the radiant. So I mentioned that meteor showers are actually as the Earth is passing through comet debris. And so it's kind of like the top figure up there driving reminds me of driving in snow. Okay. But basically picture the Earth passing through debris that's been left by a comet. And that's what a meteor shower is. So here's a list of annual meteor showers. So the deal is basically that comet debris is like set in stone. Where's the comet debris? Well, it was wherever the comet left it. So as the Earth orbits the sun, it's always the same time of year that we end up seeing these streaks in our sky passing through comet debris. So over here it says which comet left that debris. That's pretty cool. The major ones, the ones you like stay up late for or get up early for, of course in August there are the Perseids in the constellation Perseus. And coming up here, I know it's cold, but if you look at the hourly rate for the Geminids in December, it's like, oh my gosh, it can, was it 80 or something like that? I mean, it's really high. 80 an hour, which means like more than 1 a minute, right? Okay. So, what's that?
Easy lab there if you have that many.
Yeah, it's December 14th though. Hopefully you'll have all 4 labs done by then. So, but coming up, so they don't even have the Draconids up. We'll have to look at what the phase of the moon is. Well, the Taurids, that should be coming up. I don't know what the phase of the moon is. Of course, Taurids is the constellation Taurus. The Leonids, I love the constellation Leo. It's very pretty. So we'll see. All right, so I think you've heard this a few times, but just to kind of revisit the whole Pluto thing just a little bit. Pluto used to be classified a planet before they defined a planet. Okay, once they defined a planet, the criteria it failed was basically if you look at how Pluto orbits the sun, which it does orbit the sun, it is spherical, but basically it's in the Kuiper belt. Okay, what is the Kuiper belt? Well, asteroids and stuff, okay, kind of in our plane of the ecliptic. Asteroids and comets, excuse me, in the plane of the ecliptic. So Pluto is much more like a comet than it is like a planet, especially a gaseous planet. Also adding to or part of the demise of Pluto is this little object Eris down here. So remember, Eris was the object that I think he was a grad student, but Eris was actually what somebody found, a scientist found in the Kuiper belt, and it's also spherical, and Eris is larger. It's beyond Pluto, but it's larger than Pluto. So they are both called dwarf planets. And I didn't mention it, but actually right here, where to go? This right here, I know it says asteroid, but Sirius is a dwarf planet. And Sirius is an asteroid in the asteroid belt. All right. So the video talked about this with basically a comet running into the planet Jupiter and sending up those plumes of material. So I can't believe I missed it, but a few slides ago there was the word Rosetta at the top of there, Rosetta EAS, and actually Rosetta is a European Space Agency spacecraft that has landed on, or sent a lander on a comet just this summer. It's really cool. All right, so impacts. And at the top there it says Manson meteorite impact. I'm not going to take you to that website, but if you Google Manson meteorite, that's actually in Iowa. There's a site in Iowa that's kind of a remnant of an impact crater. So probably most notable would be like the video talked about, the impact that actually led ultimately to the demise of the large dinosaurs that were there at the time, 65 million years ago. I'm not sure the video emphasized this, but one of the reasons we can actually kind of link back to an asteroid or a meteor or comet actually is the presence of iridium, which is just an element that usually you don't find. It's a heavy element that usually would have, because of planetary differentiation, sunk down into the Earth, and it's carried by asteroids. All right, so will we be struck again? Will we or won't we? And the video we watched, this event here in Siberia or in USSR, Soviet Union, had not yet occurred when the video was taped. But if you guys remember back in, after Valentine's Day in 2013, there was that big, that's the meteor streaking, and of course it's an asteroid or a meteoroid falling, and they do have pieces of it. But it was captured on tape by a lot of people with their dash cams. So yeah, it's bound to happen. I know Neil deGrasse Tyson was interviewed after this, and he says, well, you know, this probably happens more than you think. It just happens over large oceans, and you really don't see it. Up there at the top, if you're interested in scaring little kids, that's NEO stands for Near Earth Objects. Okay, so basically NASA, like the video said, has been tasked with looking at objects, Apollo asteroids, or miscellaneous things that maybe have Earth in its target, and trying to decide what to do about it. So the last slide, and actually in the video we watched, they did talk about this too. The fact that kind of the gaseous planets have done a good job of playing Big Brother, especially Jupiter's the biggest of our brothers, and kind of its gravitational influence and just literally its size has deflected things that otherwise may have kind of annihilated our budding life on our planet. All right. That's all I got.